Hi there. This is a video about the Pythagorean Theorem. Now, the Pythagorean Theorem is an equation that relates the three sides of a right triangle. So an equation that relates the sides of a right triangle. All right, so let's draw a right triangle here. All right, and this is just a generic right triangle. And what makes it a right triangle is when you put in the right angle down here. All right, so one angle is 90 degrees in a right triangle. And the two parts here and here, these two sides that create a right triangle are called your legs, okay? And then the side that is opposite the right angle, all right, so it's across from your 90-degree angle, is called your hypotenuse, okay? And this is always the case, all right? And so the Pythagorean theorem states that if you take the side lengths of a right triangle, we'll call our legs A, B, and C, okay? And what we can do is we can relate them with a question. And what it means is that the sum of the squares of the legs is equal to the square of the hypotenuse. So a lot of times what you'll see is just this generic A squared plus B squared is equal to C squared, all right? So this is a formula that you'll want to memorize, and it's the sum of the squares of the legs. So take the square of one side A, the square of one side B, add those together, and that is equal to your third side squared, okay? So let's take a look at an example of a right triangle. All right, so on this part of the video, what I want to do is verify the Pythagorean theorem. Now, this triangle that you see here is called a 3, 4, 5 right triangle. It is the simplest right triangle that contains, whole number side lengths, okay? And so let's verify this. Now, what I want to do is write out the Pythagorean theorem. A squared plus B squared is equal to C squared. All right, and here's our A value, our B value, and our C value. All right, the two legs, we can say that they are A and B, and the hypotenuse is always C. So if we plug these numbers in for A and for B and for C respectively, let's see what happens. So from here, we would get 3 squared plus 4 squared is equal to 5 squared, okay? And so if we take 3 squared, that's just going to give us 3 times 3, which is 9, plus 4 squared, which is 4 times 4, which is 16. And is that equal to 5 squared? 5 times 5 is 25. Now, 9 plus 16, if we add those two numbers together, that gives us 25, and that's equivalent. So this Pythagorean theorem checks out. Okay, now let's look at a couple of examples as to where we solve for side lengths of right triangles. All right, so in the next example, what I want to do is solve for the hypotenuse, okay? And so what I want to do is figure out, well, what's the length of this part of the right triangle? And so I'm just going to use the Pythagorean theorem. All right, A squared plus B squared is equal to C squared. All right, I'm going to label my sides as A and B and C. And it doesn't matter how you name your legs. You know, this could be B, this could be A, but the hypotenuse always needs to be C, all right? And so let's plug these numbers into our Pythagorean theorem here. So what we would do is we would have that this is 6 squared plus 8 squared is equal to x squared, all right? And we are trying to solve this equation for x. So then what we want to do is let's do the math. All right, let's square these numbers. So 6 squared, 6 times 6 is 36, plus 8 squared, 8 times 8 is 64, and that's equal to x squared. All right, then let's add them together. 36 plus 64 gives us 100, and that's equal to x squared. Now, in this step here, in order to solve for x, you have to do the opposite of squaring x, and that's to take the square root. All right, so take the square root of both sides, and you end up getting that x is equal to the square root of 100, And if you evaluate that, you get a value of 10. Okay, and this allows you to solve for that length. And what we know is that the length of this side of that triangle is 10 based on using the Pythagorean theorem. All right, I want to do another problem where we're not going to get nice and neat numbers here. All right, so let's do one where we've got side lengths of 7 and 9, and we don't know the hypotenuse, and we're being asked to find what the hypotenuse is. All right, so same thing. I write out my Pythagorean theorem. A squared plus b squared is equal to c squared. I'm going to label my side lengths A, B, and C. All right, and let's substitute those in. So I'm going to write 7 squared plus 9 squared is equal to x squared. All right, so now let's do 7 squared. 7 times 7 is 49. Plus 9 times 9 is just 81, and that's equal to x squared. Now, when we add these together, we've really got 49 plus 81. If you take the 1 and move it over here, that's 50 plus 80. This is 130. All right, 130 is equal to x squared. Now, 130 is a number that we can't take the square root of and get a nice, neat number. All right, so if we take this, let's apply the square root to both sides of that equation to get x by itself. X is equal to the square root of 130. Now, if we go into our calculator and do the square root of 130, then we should be in between 12 and 13. Oh no, I'm sorry, it should be less than 12, between 11 and 12. And so this gives us an approximate value of 11.402. All right, if you rounded that to 3 decimal places. Okay, so rounding is a big thing here, but using this formula allows us to figure out that side length. Okay. So another way where we could use the Pythagorean theorem is when you're solving for a leg of a right triangle, meaning like one of the sides, not the hypotenuse. So when you do this, you're going to do the exact same thing. Set up your A, B, and C, and let's write out our Pythagorean theorem. The only difference is that all of a sudden our x value is in the B spot, not on the C spot. All right, so let's do this. Let's go a squared, which is 6 squared, plus x squared is equal to 11 squared. All right, so now instead of, now you've got x squared on one side and you've got to move this 6 squared over. Let's go ahead and just square these numbers first, and that's going to give us 36 plus x squared is equal to 132. All right. Subtract 36 from both sides at this point, which is different than what we were doing before. All right, we're just solving for x, and so now you've got x squared is equal to, all right, let's do 132 minus 36, and that's going to give us 96. All right, let's apply the square root and take that of both sides, and so when we take the square root of 96, we don't get a nice, neat number, all right? But we can get an approximation. X is equal to the square root of 96, but then we can come in here and say that x is approximately equal to 9.798 if we round that to 3 decimal places, okay? And you're finding out what that is. So depending on what you're doing, depending on how you're rounding this, but just know that typically I go out to 3 decimal places, but look to see what, you're doing on whatever assignment you're working on. So that's how that is what the Pythagorean theorem is. That's how we use it. That's the different kinds of problems that you'll see. And so I just wanted to go through that, have a few examples written down, and, please reach out if you have any questions. Thanks a lot. Bye.